Okay, let's get started. So let's go over the three. The results of the My Math Lab were very good. I think the lowest on any My Math Lab assignment this far has been like 85% as an average. So you guys are doing very well. But let's just go over the three most commonly or gave you the most trouble. This was the first one. And so we just have to, the key is understanding what the notation is telling us. When you read these symbols, do you understand what that's telling us? So this right here, d dx. What is it telling you? And what does that mean? Find a rate of change function for this accumulation function, right? Let's find a rate of change function for that accumulation function. So we want the rate of change of, okay, and what's the first question we ask when we want to find the rate of change function? What's that? What's the overall structure of this accumulation function? What is it? Product, okay. So we've got x and f. So the rate of change is the first times the rate of change of the second plus second times the rate of change of the first. So what's the rate of change of x? 1. Okay, the rate of change of x is 1. Think of an accumulation function, that's x. What's the rate of change of that function? For every change in x, what's your corresponding change in y? Now I'm getting tricky on you. For every change in x, what's your corresponding change in y?
1.
Not 1. What's that? It's the same, right? It's 1 times the rate of change of x, or the same. Okay? It's the same as the change in x. That's our rate of change function of 1. Okay? All right, so now we want to evaluate this. This is saying, this is what that little comment I give you, evaluate that at x equals 4. So now we want this thing evaluated at x equals 4. So x is 4. So we know 4 times the rate of change at 4 plus the function at 4 times 1. And here's where the table comes in. So what's the rate of change at 4? The rate of change. And this on mine is 4. That's the rate of change when x equals 4. An unfortunate result. It's a little confusing. But the rate of change when x is 4 for my table is 4. And then what is f of 4? That's 2. So my answer here would be 10. Questions on that one?
18.
You're so smart. 4 times 4 is an 8? 18. Thank you. Okay. Any questions? Does it make sense? So, knowing what the symbols mean. 13. Okay? We want to find the closed form rate of change function for this accumulation function. What's the first question we ask?
The overall.
The overall structure. What is the overall structure? Some are saying product. Is it something to a power or is it a product? Product. Okay, so let's name this F and name this G. And then our overall answer will be of the form the first times the rate of change of the second plus the second times the rate of change of the first. So our intermediate step then, the hard part here is identifying what is the rate of change of the second function, what's the rate of change of the first function, and then our final answer will be of this form right here. So we'll go with f prime first. what is the rate of change of f with respect to x? Yeah?
4 times quantity 5x minus 1 to the third power times 5.
Outside-in approach. Okay, so we've seen two approaches to this, an outside-in and an inside-out. When you got an easy chain rule like this, only one layer deep, outside-in is totally fine. I recommend when it's a multi-layer composite function, maybe try sometimes going inside-out, which I showed you an example last time, maybe help. But this is, are we agreement, that's the rate of change of f? And then the rate of change of g. Rate of change of g. Christian.
2 times 1 minus x to the power of 4.
Okay.
Times 4x cubed.
Fell for it, as many of the rest of you did. What's the rate of change of 1 minus 4x to the fourth? Negative. Right? Yeah, but you're not alone. I think a lot of people make that mistake. Okay, this is really the rate of change of negative x to the fourth, and so negative 4x cubed. So the rest would be just typing the whole thing in. We've got f, we've got g, we've got the rate of change of f, the rate of change of g, and we're gonna type that in. I'm not gonna take the time to do it. Questions on this one? So we got all the pieces, we just got to put them together and create this expression right here. Any questions before we go on to the last one? Last chance. Okay, the last one was 15. X cotangent okay, overall structure of this accumulation function. Overall structure of this accumulation function. Product. What do you think? Agree with that? Sum. Yeah, so the meat of the problem is product, but really the overall structure, do you see that it's a sum? Okay, so the rate of change of h is going to be what? The rate of change of that plus the rate of change of 2. What's the rate of change of 2? How fast does 2 change as x changes? Doesn't change, 0, right? So now, the overall structure of the accumulation is sum, but all the work involves this part of the sum, which is product. Okay? So let's call that f. F and G. So, rate of change of F, 1. Saw it earlier. Rate of change of G. Okay, rate of change of G. Okay, so the overall structure is, what is the overall structure of that? Cotangent, right? With a composite is a composite function on cotangent. So the overall structure of this is cotangent. So many of you said, what was it? Negative cosecant squared? And that's it, right? Okay, this is a composite function. So really, when x starts going through this function, it first is, first we have the rate of change of this. And so what's the rate, and that's what we don't have now. What's the rate of change of 4 radical x? 4 over 2 radical x.
You don't want to simplify more than that?
You don't need to. I mean, you can, but you don't. For our purposes here, we're just writing out. If I simplify it, then you can't see where it came from. As easy. But yes, you can. But for your test on Thursday, don't do any simplification. Okay, so then we've got it'd be the first times the rate of change of the second plus the second times the rate of change of the first. And so this right here is our rate of change of the second. Okay, questions on these examples, this homework? Okay, let's talk about your mastery test on first attempt on Thursday. So I've posted, if you go to assignments and you look at today's, you should have seen today's post. I posted a problem list of 48 problems, 10 of exactly those problems will be your mastery exam. Okay, well, half of it. And then the other part will be short ones, which will work. I'll show you what I mean today. So here's the list. Hopefully you've already started chipping away at these. Some are medium hard, some are more complicated. Okay? Question? Yeah, question.
Okay, we've done the derivatives for the arc, cosine, and tangent. So it's all memorized?
Yes.
Okay.
Mastery exam is a memorization activity. That's what it is. It's part of the 270 course. And so these are the 48 possible questions you can get on your mastery exam. You'll get 10 of them, just as they are here. You're going to get 10 of these. Okay? Here I've also posted in that same post for today's homework the rule summary list. Here's that. I think Melody's been requesting this several times. So here it is. I've got all the basic rules. I've got all 6 trig rules and all 6 inverse trig rules for closed form rate of change. And then at the bottom, just our general rules. A constant times a function, a composite function, a product of functions, a quotient of functions. So those are our general rules at the bottom. And then here's everything you'll be responsible for on the test. So yes, this is an exercise of memorization. Part of the 270 requirement. Yeah?
Do we have to know like the trig identities? Like sine squared plus cosine squared equals 1 and stuff like that?
No, because you're just using the rules to find the closed form rate of change. There will be you're not doing any simplifying. This is what you need to know and how to apply these within all the rules in combination. Okay? All right, so that's posted for you to look at. So, like I said, half the exam will be 10 of these. The other half will be 25 like these. So on your computer, why don't you open up, since many of you probably haven't memorized these yet, open up this page that you can get to on Blackboard and have this in front of you on the computer, and then I'm going to put some examples of short, quick ones that'll also be the other half of your mastery exam, and you have this on your screen at your disposal. Nope. Okay, hold on a sec. All right, so for Wednesday, there's no homework. Wednesday, study for the mastery exam. Pass it on the first attempt. See November post below for the complete problem list and the summary rules list. Okay, and then in recitation, you can take recitation time to work on these. Okay? Recitation time. There won't be a quiz. Both Tuesday and Thursday, you can take time to work on these. If you want to go to both recitations, you're welcome to. So go to your own, and then if you want to go to the other one too, you're welcome to do that. It's the same time and place on Tuesday or Thursday. Questions?
Same rules as the test.
Same rules.
Like
Procedure.
Yes.
Yes. So the mastery exam will be in the testing center. It's open 10:30 to 6:30. Okay. All right. I feel like not everyone's paying attention. Why do I feel that way? Still not. Okay, so the procedure for taking the exam is the same. I just don't want to have to repeat myself. Are you listening? So the procedure for taking the mastery exam is the same. You'll go on Thursday between 10:30 and 6:30 to the testing center. And this is, you're writing out result. It's not Scantron. You are writing out the first step of finding the rate of change function for the given accumulation function. Again, half of them will be from this list. Half of the exam will be 10 of these. The other half of the exam will be ones like this. Just short, rapid fire. Do you know the rules? So let's practice. Take 5 minutes. If you bring up the summary rules list on your computer screen in case you haven't memorized all the trig and the inverse trig, that will help. So let's practice rapid fire. This is the other half of your, something like this, not these exact questions, but the other half of the mastery exam is like this. So let's just practice to get the hang of it. Go. And I'll take roll. Yeah.
Can we have a calculator in there?
You shouldn't need a calculator. Nope, no calculator. So because there's no calculations to do. You just memorize the rules and you apply the rules.
Yeah, my quick math's not so good.
It's got to get good. No, what are you going to use a calculator for? Simple math, exactly. You should be able to do simple math without a calculator. Kevin. Natural log. That's natural log.
That's 2 ln.
2 natural log of x. Is that better? Yeah. Okay, I know the writing isn't great here. Any others you want to clarify? Similarly, natural log of 7. I think the rest are good. Okay, go. Work on these. They're coming back. Okay, I'll make one round and then we'll talk about your requests.
Okay. I just did this one.
Oh.
I did my
No, we didn't cover the class. I'll explicitly say, I'll explicitly say, here's something you want to do in class anyway. So you'll know.
It's just literally having to remember.
Okay, requests. What should we do? 15 for sure. Okay, what else? 13? Okay, so 13. How is it different than e to the x? Yes, it's a composite function. It's 2x plugged into e to the x. So, but the overall structure is still e to the something. So what's the rate of change of e to the something? E to the something. But now, this is a composite function. And so we also need times the rate of change of the interior function. Okay, what's the rate of change of ln of 7? It's not 1 over 7, okay? Many have tried, but that's a number, so it doesn't change, so its rate of change is 0. Sine of e, 0. Because the rate of change is 0, because that's a number. Pi to the 1.5. 1.5 pi to the 0.5. Right? No, rate of change is 0. So be on the lookout for numbers like this. They might look like the power rule, or it might look like some other rule, but if it's just a value, its rate of change is 0. So then you said, question?
Yeah, I have a question like on the horse and so on this.
Let me do number 15. So I think for 15, it helps to start. So you can work out quotient rule with composite. That's a lot of work. A good thing to do is start off by writing this as x to what exponent? This saves a lot of time.
Oh, 2/3.
Negative 2/3. That's what that equals, right? So the power is 2. That's the numerator of your exponent. The root is 3. That's the denominator. And this is in the denominator, so that's the negative. So for these little easy ones that you can rewrite as a power rule, do that. Don't work out quotient rule on this. You're bound to make it. Not bound, but you much more likely to make a mistake trying to work out the quotient rule here than just changing it to its equivalent, and then we got,
Could you work number 2 the same way?
what's that?
Could you work number 2
Yes.
the same way? So it would be x 3 and 2.
Yeah, let's do that in a second. Okay, so this is negative 2/3 x to the, okay, so we can stop right there.
On the exam, if we left it as negative 2/3 minus 1, could we just like that?
Minus 2/3 minus 1.
Because you subtract 1.
No, you need to write the new exponent. Never write minus 1. Write the new exponent.
Wouldn't you have to do the derivative of the composite function instead?
No, it's just the power rule. It's just x to a power. There is no function there. If you do quotient rule, yes, then you've got, when you get to the rate of change of the denominator, then you got a composite function. But if you switch it to a power like this, you're done. You're done. So similarly, how would we rewrite this first one? Or number 2, x to the, x to the power is 3 now, and the root is 2. Easy. Can you take it from there? Okay, any other questions? Okay, half of the mastery exam, 25 questions just like these. The other half, 10 from the list of the more complicated ones. That's your mastery exam. So there's no, so we've already started, we already know 60-70% of this stuff. Now you got 3 more days to master it. So everyone should be out of here in that first attempt. It's just a matter of putting the time in. Okay? So put the time in now instead of having to go to the testing center another time next week and get a lower grade. Okay? Let's get 100s. Everyone get 100. So you need to get 90% of everything correct. Questions?
If you were to do this one with just a rule, would it be like 3x squared over 2 times the square root of x?
This is the last one?
Yeah.
So you would have the rule would be, the overall structure would be square root. So you'd have 1 over 2 square root. And then
That's sine e,
you need to square it. And if you simplify that, you should get exactly the same as
I was thinking the e was
3/2 x to the 1/2.
yeah. Base.
So simplifying that should give you will give you this.
It's just numbers, right? E's, it's just numbers.
Last chance for questions about the mastery. We're going to move on to new material.
So you just take
Yeah.
Memorization, can we like go over,
just that.
Yes, you can go over problems from the list. Yep, for sure. You can work on them. Other questions? Okay. So what I want you to do is go there to Blackboard, and if you scroll down, or I'll move it up. Hold on. So go back to the Blackboard assignments and come on. Okay, on Blackboard assignments, refresh right now and get this GC file that I just posted. GC file for class 11-4. And open that up. Open it up, but don't do anything yet. Okay, so keep passing them into this corner. That's where they're. Okay, once you have that open, so open it and it should look like this. With a, you might have a comment up here. It says what is that? I'll just open it. Okay, this is what it should look like. Does it look like that? Once you get it open. Okay, so we have this expression, a squared plus b cubed minus 2ab. And what we want to do is we want to find all, and so a is, the value a is the x-coordinate, and the value b is the y-coordinate, and so we want to find all points in the xy planes. If a is the horizontal coordinate and b is the vertical coordinate, all points so that that expression of a and b equals to 7. Okay, and so here's what you can do. So if you take the cursor and you move to the red point, a crosshairs will come up, and then you can drag it. And as you drag the point, a and b are the x and y coordinates up above, and then the value of the expression a squared plus b cubed minus 2ab shows up for the current values of a and b. Does it make sense? So right now, my x value is 4.22, or a. My y value is 1.55, and the value of the expression is 8.45. So what we're looking for is we're going to move around. We want to look for all the points that makes this expression equal to 7. So now let's try one over here. So I'm going to come over here. And we just need to, there we go, 7.02. Okay, so here would be a valid point. X, negative 0.184. Y, 0.828. Makes this expression 7. Essentially 7. Okay? And so you don't have to write down coordinates. All you have to do is find this, and now on the paper that I just gave you, now you're going to plot this point. Plot the point, negative 1.84 and 0.828. And that's 1. You found one, right? You found a point such that the coordinates make this expression equal to 7. So plot that, everyone plot that point. Question?
Sorry, how did you do that?
You put it on the point, and it should come up with crosshairs, and then you just drag.
What's really other points? 6.9.
Yes. Yeah, in between 6.95 and 7.05 is close enough. So you need, did you hit graph yet? Click on graph so the red point comes up, and then you can move it around.
You might have to zoom out. I have to zoom out.
This is the good window, from about -8 to 8 and about -3 to 4 is a good window for this. Okay? So you don't have to write any values down. Just find the points and then use the coordinates to plot on your paper. So you're going to plot all the points such that the coordinates x and y make this expression equal to 7. So the goal is as many points as you can find. So don't find a method that's efficient and fast. Okay? Don't spin your wheels making tables of numbers. Okay? Just we want to get the points plotted on the paper. So go, and you can work together. So especially, is there anyone who can't see a screen? Anyone that can't see a screen with GC? Everyone's good? Let's see. So let's see. What about, would you mind trading places with Lima? Sure. And then bring your computer with you. Thank you. Anybody else? Can everyone see a screen?
How close is 7?
Between 6.95 and 7.05. Between 6.95 and 7.05.
Got it.
So the goal is fast, rapid fire, find these points. And find them in all 4 quadrants. Find them in the first, the second, the third, the fourth quadrant. Find the points. Find the points that make that expression equal to 7.
Yeah. Awesome.
Go from about -8 to 8 and -3 to 4. Points? Okay. Yes, you're right. Like I said, try to find them in all 4 quadrants. Like, don't find 10 points that are all within an inch of each other. We want to get an overall picture here. All 4 quadrants. Okay, all right. Oh, what's that? On the copy?
We want to do 3 in each column. Find the 2. So I'll translate it on this way.
Is this one?
Okay, did you find them all yet?
Every single one.
Keep going, every single point. Are you getting something that's kind of forming like this?
Yeah.
Anybody get all the points? Why not? Supposed to get all of them. That was the goal. That was the task. Sure, right. That's so I'm being funny, right? So, and apparently it worked, I guess. So there's an infinite number of points, and they seem to be all kind of on a string, right? Like they're kind of a string of points and these locations that all make this expression equal to 7. Okay, so Sterling had an idea to quickly find all of them. He found all of them very quickly. Sterling, what'd you do?
I put the equation a squared plus b to the third minus 2ab. I put x for a and y for b.
X squared plus, is this what I mean?
Y to the third minus 2xy
Okay.
equals 7.
And what will happen when I hit graph?
We'll find all the points for you.
Okay, so now I'm gonna turn off the points that I plotted. Okay, I'm gonna turn off the points that I plotted. Ready? Oh no, that's not what I'm asking. This. Okay, and I'm gonna.
Well, you guys didn't. It's a 3D graph, but I didn't know it did that.
Okay, so my question is, how many points are there now? I took all my points off. All the points I plotted, I took them off. How many points are there? 0, right? Good. Okay, so when you look at this graph, what constitutes a graph? What constitutes a graph? It's a bunch of points, right? It's a bunch of points. Which points are they? So in this graph, which points are you looking at?
All the equals.
Okay, all of what?
All the points, like all the x and y coordinates that would equal 7 in that function.
Right. He said all the points whose x and y coordinates would make this expression equal to 7. Right? Okay, so this point right here. Tell me about that point right there. Jonathan, I plotted a point in red there. What can you tell me about that point?
Well, I'm not sure.
Not sure. Gilbert.
I'm sorry.
So this point right here, I plotted this red point right here. What can you tell me about that point?
It is on the graph, and it is equal to 7. Your
It
x
is
and y.
A point is not a value, right? What is equal to 7?
Your a and b coordinates when plugged into the function come out to 7.
The x and y coordinates of that point, when put into that expression, will give 7. That's what you can say about that point. Okay? Kaylin, what can you say about that point right there?
Let's see. Well, you could plug the coordinates into the a squared plus b 2
Okay.
plus 2ab, but it wouldn't equal 7.
It wouldn't equal 7. You could plug the coordinates x and y into that formula, but it won't equal 7. Right? So this is showing us every single point in our view so that equation is satisfied by the x and y coordinates. Okay? So, is it a function? This graph, is it? Oh, okay. So here's the thing. Lots of students. Let me just summarize. Lots of students. They see this. They see the graph, and they see this: x squared plus y cubed minus 2xy equals 7. And their view of this right here is, this is the name. This is the name of that curve. So when you have this curve, that's what we call it. Okay? But that's not what it is, right? This curve is a mathematical representation of that formula, or of that expression, do you see? It's every point whose x and y coordinates make it true. So this isn't just the label, or what we call this particular curve. All we call this curve, x squared plus y cubed minus 2xy equals 7. No, this is generated as a representation of this mathematical statement. Does it make sense? It's really important. Okay? So, is this graph the graph of a function y as a function of x? Is it a graph of a function y as a function of x? Yes or no? Why not? Steve, why not?
Well, you can't tell, can you? Because it's not solved for y.
Okay.
That expression is not a function of 7.
Okay.
Because that violates the vertical line law.
Oh, okay, so tell me where you're looking on the graph. You're looking at the graph?
Yeah, from 2 to 4.
2 to 4, for a given x, what happens?
It violates the straight line. So
Right.
you're getting 2 values.
So for instance, for this x value right here, we get 3, right? Maybe more that we don't see below. Okay? So first, there are x values that have more than one value of y that satisfy that. Therefore, y is not a function of x. Can we talk about the rate of change? So it's not a function. Can we talk about the rate of change of y with respect to x? If it's not a function? Yes or no? Can we talk about how y changes as x changes?
Yeah. Find the derivative.
How about right there? Can we talk about the rate of change of y with respect to x?
As long as it's in
proximity.
Yeah, we're just talking about that right there. Yeah, sure. And then also there, even though they all have an x coordinate of 3, as long as we're in the vicinity that we specify, yeah, we can still talk about the rate of change of how those y with respect to x, even though y is not a function of x. And that's what we'll do on Wednesday. Okay?